Now, some of the terms I've been throwing around quite a bit are class, instance, and object. And I'll admit, sometimes I use them interchangeably because just after writing object-oriented code for so many years, the concepts just kind of blur together in some ways. But it's worth us taking a minute to kind of define more precisely what they are, so that at least at one point in time we kind of agree with what they mean, and when we need to be precise about what it means, we can be precise. So what's a class? What's an instance? And what's an object? Okay, so a class is a specific C++ syntactic construct for describing some kind of object. And in fact, a lot of object-oriented programming languages use the keyword class to denote a way of describing an object. So like when I wanted to describe the rectangle object, right, we declared this, this class called rectangle with these various members. Okay, this is a description of an object, but it's not an object yet. It is just a class. It is a way of describing a kind of object we're eventually going to have in our program. Now, an object, on the other hand, is something that occupies memory. Technically speaking, the class itself doesn't occupy memory. It's just like a pattern for the types of objects we're going to make. It's a type. It's not an object itself. But when I actually declare a variable of type rectangle here, then I'm making an object. R is an object. The rectangle is a class. When we declare a variable of type rectangle, we're actually reserving some memory for it. That variable R is going to take up some memory somewhere in the program. It's either going to be on the stack if it's a local variable. If I declare it using malloc or new, it's going to be in the heap, or it could be a global variable in the global data section. But when I declare R, it's actually occupying some memory somewhere, and that makes it an object. The class itself takes up no memory on its own. If you just declare a bunch of classes, but you don't make any variables of that type, they took up no memory, and no memory was used in your program. Which is why you can include a bunch of header files in a C or C++ program, as long as you never declare a variable of those classes you include, then they take up no memory. They're not going to be part of your final program. Okay, and then when object, we like to call it an instance of a given type or class. So here I have my class rectangle again, and when I declare R is an object, but then I would say R is an instance of rectangle. And in C++ at least, we don't restrict instance to only refer to objects or classes. You can actually have an instance of a variety of things. Now, S is a string, and so when I say string S, then I would say S is an instance of string and S is an object. And X is an instance of int. Now, in the most strict sense, maybe X you wouldn't think of as an object because it's a primitive type. But technically, X takes up memory, and so by definition, you might still call X an object. It kind of depends on how liberal you want to be with that term. Also, it's worth pointing out that members of an object can also be objects. And so in this more liberal definition where I say anything that takes up memory is an object, then integers also take up memory, and integers are also objects. And so that means that width and length inside of R are also objects. So r.width and r.length are objects, and they're instances of int. Okay, so summary, a class is a description or a definition of an object type. It doesn't actually allocate memory anywhere. It just says later we may make a variable like this class, that's of this class. An object is made when declared, right? And an object takes up memory. And then an object is an instance of some type. And often we'll talk about objects being instances of some kind of class. Specifically, since we're very interested this semester in user-defined types and user-defined classes, then a lot of times we're going to be talking about objects that are instances of some class type that we created.